Welcome to the CalSim tutorial. Today we're going to show you how to use our model. We're going to start off with the website. To begin using this product, go to the Download tab and download the zip file titled Disaster Relief Simulation onto your desktop. Now right-click on the zip file and extract all. Open the Excel spreadsheet. Enable macros. This is the main page of the Excel model. On the left, you'll see the 7 types of user-controlled variables. On the right are the variables which will trace the death count and survival counts as they increase, and the victim counts as they decrease when people die or are saved. Now click on Set Up Experiments, which will take us to the Experiments tab. Here we can input all necessary parameters. This is the color for cells that may need an input value. The random number seed is very important for randomness to occur in the delay times. The run time should be very long so that the simulation can run through all victims in the system. The number of victims is specific for each type in the order that the user wants them to be saved. The ideal example in this case is for the most urgent group of victims to be helped first. The next group of variables is the number of servers, which helps an emergency response agency understand the effectiveness of an additional resources. The server batch size is specific for the server vehicles, for how many victims a vehicle can save. The next group is the data for a server to arrive. The randomness is created by a triangular distribution, by inputting the minimum, maximum, and most likely time for the server to arrive. We use the triangular distribution since it's realistic, as it does not have any infinite tails or negative values. We input the same kinds of values for the time it takes to save a victim. This is important since more urgent victims may take longer service times. Finally, we input how often people will die in the system and the death rates at which a victim type will die. For example, every 50 time units, 10% of the first victim class will die. For more details, see the technical appendix which can be found on our website. After confirming that all the cells of the color have appropriate values, click on the Run Simulation button. You will find yourself in the Simulation tab. Click on Simulate. Since you've already inputted all the necessary data in the previous steps, click Yes here. Now an MS-DOS prompt appears. It asks if we understand that we need to obtain a valid license for commercial use of the product. We comply by entering the requested number and hitting Enter. You will do this 10 times until the MS-DOS prompt disappears. Now, you'd like to import your results, so click OK. This will take some time, so we wait. You may have noticed that the temp simulations ran very quickly. This is because we are running a pure resident entity model. Once this is done, we can now click OK to view our results. By clicking on the different buttons, you can view different plots or the confidence interval information. If you go to plot 1, you'll see that as the death count and survival counts go up, the victim counts go down. All of these plots are similar since they have the same parameters, but they're slightly different due to randomness. You may also view the confidence intervals for our experiments, which in this case are 1658 to 1707 for the death rates, for the death count, which yields a mean of 1683. You may now continue analyzing the plots if necessary. We're going to now try some more experiments. We will change the priority of which victim group gets helped first. For example, the experiment which we just ran has the priority of victims in order of urgency. We can now switch the first and second groups, which means that the most urgent group will be served second and the second most urgent group will be served first. We basically just switch all the data from the number of victims, the time to save a victim, and the death rates. Now we run the experiment again using the same process as outlined previously. You'll notice by looking at the confidence interval tab at the mean death count that this is significantly lower than in the previous experiment before we made the switch. In this way, FEMA or other emergency response agencies can use our product to analyze different methods of response to save more people. This model is also powerful since we can change the parameters like number of victims and death rates to better represent different kinds of disasters. We can also conduct sensitivity analysis on the number of servers and server batch sizes. This is important because response agencies do not have unlimited resources, so this product can help manage resources efficiently. As you can see, this is a very powerful model. I hope this tutorial was useful in understanding the product. Thank you.